Evening all. Now I would like to discuss about series and parallel connection of resistors. Okay, first we will discuss about series connection of resistors. Okay, let us consider three resistors R1, R2, R3 are connected in series across a supply voltage of V volts. Okay, because of this battery voltage, current I is flowing into the circuit. Okay, now you can see here current I is flowing into the circuit. Based upon this current direction, across passive elements polarities will be plus minus, plus minus, plus minus. Okay, that means the voltage across first resistor will be V1 and the voltage across second resistor will be V2. The voltage across third resistor will be V3. Okay, then apply KVL to this loop. Okay, you will get here minus plus minus V, plus minus plus V1, plus minus plus V2, plus minus plus V3 is equals to 0. But already we know that voltage across any device is nothing but current flowing through that branch into that branch resistance. See here, V1 is equals to current flowing through that branch. In series current is same, right? That is I, voltage across that branch. That means V1 is equals to I into R1. Similarly, V2 is equals to I into R2. V3 is equals to I into R3. That is minus V plus V. In place of V1 I can write I into R1 plus I into R2 plus I into R3 is equals to 0. Okay, then V is equals to I into R1 plus I into R2 plus I into R3. If I take I as common, I will get R1 plus R2 plus R3. Okay, from this equation, if I take I on LHS side, I will get V by I is equals to R1 plus R2 plus R3. Already we know that from Ohm's law V by I is nothing but R. Okay, then total equivalent resistance R equivalent, hence R equivalent is equals to R1 plus R2 plus R3. This is for 3 resistors. Okay, for n resistors, the equivalent resistance formula will be R equivalent is equals to R1 plus R2 plus R3 plus so on Rn. Okay, that is the equivalent resistance in case of series connection. Okay, in series connection major important points will be in series current is same, voltage across different resistor is different. Okay, next, total voltage is algebraic sum of all voltage drops, that is V is equals to, from this equation V is equals to V1 plus V2 plus V3. Okay, that is about series connection. Next we will discuss about parallel connection of resistors. Okay, let us consider two resistors R1 and R2 are connected in parallel across a supply voltage of V volts. Okay, then current I is flowing into the circuit, right? This current I is divided into I1 and I2. Okay, here it is a supply voltage will be V. Okay, voltage across the first resistor will be V1 and voltage across the second resistor will be V2. But already we know that in parallel voltage is same, that is V is equals to V1 is equals to V2. In parallel voltage is same. Okay, you can remember this point. After that, apply KCL at this junction. You will get I is equals to I1 plus I2. Okay, that is I is equals to, already from Ohm's law we know that I equals to V by R, right? That means I1 is equals to voltage across first resistor will be V1 by R1, but already we know that V1 is equals to V, right? Then I can substitute V only. I will get V by R1 plus similarly I2 equals to V2 by R2, again V2 is equals to V, then I will get V by R2. Okay, if I take V as common on RHS side, I will get 1 by R1 plus 1 by R2, that is I equals to V into 1 by R1 plus 1 by R2, that is I by V is equals to 1 by R1 plus 1 by R2. But V by I is nothing but resistance, I by V is nothing but 1 by R equivalent. Okay, that is, see here 1 by R equivalent is equals to 1 by R1 plus 1 by R2. This is for 2 resistors. Similarly for n resistors, 1 by R equivalent value will be 1 by R1 plus 1 by R2 plus 1 by R3 plus so on 1 by Rn. Okay, now this equivalent resistance will be calculated for 2 resistors. From this equation, 1 by R equivalent can be written as LCM will be R1 R2. In numerator you will get R2 plus R1, right? Then R equivalent is equals to R1 R2 by R1 plus R2. That means when two resistors are connected in parallel, R equivalent formula will be R1 into R2 by R1 plus R2. In case of 3 resistors, R equivalent is equals to R1, R2, R3 by R1 plus R2 plus R3. Okay, maximum number of students doing like this only. This is absolutely wrong. Okay, why? Because here 1 by R equivalent formula will be 1 by R1 plus 1 by R2 plus 1 by R3. You need to simplify from this formula for more than 2 elements. If you simplify this for 3 elements, you will get R equivalent equals to R1, R2, R3 by R1, R2 plus R2, R3 plus R3, R1. If you simplify this equation, you will get this value for 3 resistors. Okay, that is about equivalent resistance. Okay, now see here, for example, here for 2 resistors, the equivalent resistance formula will be R equivalent is equals to R1 into R2 by R1 plus R2, right? Suppose here I am assuming that all values will be equal in parallel. R1 is equals to R2 is equals to R. Okay, that means then R equivalent will be R into R by R plus R, right, for 2 resistors. This is the formula for 2 resistors, right? Then I will get R square by 2R. Then I will get R by 2. That means if equal values of 2 resistors are connected in parallel, resultant value will be R by 2. If 3 resistors are connected in parallel, resultant value will be R by 3. That means if 100 resistors are connected in parallel, then resultant value R equivalent will be R by 100 if equal values are connected in parallel. This formula very important for competitive exam point of view. That means you will get a question like this: if 100 ohm resistors are connected in parallel, what is the R equivalent? Blindly you can put 100 by 100, 1 ohm is the answer if you know this logic. Otherwise it will be complicated. Okay, next we will discuss about voltage division rule and current division rule. Okay, voltage division rule is applicable in series circuit. Okay, now see here it is a series circuit. Okay, by knowing the total voltage, directly we can calculate V1, V2, V3. Okay, without knowing current I. Okay, that is nothing but voltage division rule. Okay, here see here, voltage across any branch is equals to total voltage from this equation, total voltage into that particular branch resistance divided by sum of series branch elements. This is the formula. Okay, now see here, first we will discuss about voltage across resistor R1. Okay, that is V1 is equals to total supply voltage V into R1 by R1 plus R2 plus R3. Okay, that is voltage across first branch is equals to total supply voltage into that particular branch resistance divided by sum of series branch elements. Okay, similarly voltage across second branch, V2 is equals to total voltage into that particular branch resistance divided by sum of series branch elements. Okay, similarly V3 total voltage into that particular branch resistance divided by sum of series branch elements. Okay, in this way we can calculate voltage across any branch by using voltage division rule. Next, similar way, current division rule. Current division rule is applicable in parallel circuits. Okay, see here, by knowing the total current, okay, by knowing the total current, we can calculate parallel branch currents. That means here I know I value, right? Then by knowing this I value, current flowing through resistor R1 is equals to, that is current flowing through any branch is equals to total current into opposite parallel branch resistance divided by sum of parallel branch elements. Okay, now see here, from this figure, first I need to calculate current flowing through resistor R1. Okay, that is I1 is equals to total current into opposite parallel branch resistance R2 by sum of parallel branch elements. Okay, similarly current flowing through second branch resistance R2 is equals to, that is I2 is equals to total current into opposite parallel branch resistance divided by sum of parallel branch elements. Okay, in this way we can calculate current flowing through the parallel branch elements by using current division rule. Okay, I hope all of you understood. Okay, thank you all.